Awesome. So we're going to connect up to an IEC 61850 device. And like most of our configurations, pretty straightforward. So in the gateway, we're going to come down and add a new device connection. We're going to create a new device, and we'll select on that IEC 61850 MMS client driver. And it is, like I said, straightforward in connecting up to these devices. We're going to name this IEC 61850 device, and I know my host name is this IP address. Under advanced properties, I'm going to use or set the use SCD file to true. So an SCD file describes the entire substation in detail, including the communication, IED, and data type template sections. We'll utilize the same SCD file used to define all of those reports available to Ignition. So I'm going to select that, and I'll use configured host name as well. And you can see there's a lot of other options for configurations in here, and you can absolutely configure this to meet your needs. So we'll create that new device. We can see that we're connecting, and we're connected that quick. So at this point, we can see that we're connected, but we also need to import that SCD or substation configuration description file, is what that acronym stands for. It's advisable to use an SCD file if you want to control request size, access point visibility during OPC browsing. This helps to reduce the load on the substation device. Without an SCD file, the device connection restarts and can lead to heavy network traffic, as well as all defined logical nodes from the specific ID are requesting that OPC browsing. So on SCD, I am going to choose a file. And at this point, I have them saved in this location, and we're going to upload that. And we're good to go at that point. Now we can navigate over to our designer, and we've set up different tag browsers for each one of these devices, just to keep it simple and for yourselves that you can not be as confused by as much going on. So in the designer, we can now browse that device, and we can see we have a bunch of reports in the folder. One important thing to note here is if multiple systems need to connect up to the same device, reports are limited to one subscription per report. And these are all configured within the software that defines the SCD file. So if two systems need the same data from the device, separate reports will need to be developed at the SCD or IED level. In this case, we're going to be utilizing this second report on the list, but we've pre-built some UDTs to make this a little bit simpler and quicker. So we're going to set up that UDT. So you can see I have that UDT definition already defined within this section, and we're going to create a new instance. So we're going to name this B1XCBR1, which is breaker 1 XCBR1. Anybody in the energy field would understand the context there. Under parameters, we just want to make sure that we have our device name named the same thing as what we hooked up here. In this case, it is. The other items in this list, we'll get into a little bit more detail on some of those system functions and how we're retrieving these values. So I'm going to hit apply. And we'll see now that we have that UDT instance in our tag browser. In perspective, I've built a few views to demonstrate these system functions that we talked about earlier. So we'll come into IEC 61850, and for right now, I'm just going to open this main. And on this very simple view, I have an SVG and a button, a one-shot button. If we look at the one-shot button, it is utilizing those parameters that we defined in that UDT model to send an operate command. And we'll demonstrate this working. In this case, we'll operate it off, it's sending it, and watch it change in our tag browser, and then we'll change it back. So also another important thing to note here, why do we have these system functions? Because we can't write directly to tags within the IEC 61850 device, hence requiring those system functions. The next item I want to look at briefly is the get control params. So like I said, we have these parameters to make those requests to operate a breaker. And what I'm doing here is I'm pulling that device for all of its control params. Those control params are listed over here in this custom property. And if we look at that binding, very simple binding, all we're doing is pulling in the device name and running that system function. And it's returning this list of dictionaries for each item on here. In our case, we're looking at XCBR mod 1. And what we can see is that our parameters in here match the parameters for that mod 1. And then the last item I want to demo here is downloading files from the IEC 61850 device. So if we put this into play mode, we can see we can come in here and I have this drop down of 3 different items. Those items are actually coming from that IEC 61850 device. In the custom properties field over here, you can see we're requesting those files with the IEC 61850 list files. We can also download those files from that device by executing a simple command, and we'll look at that script real quick as well. Well, we're just pulling in parameters. Mainly, we're looking at what the device name is, where the path within the device is, and where we want to store it locally. So we'll run that real quick and download. Right now, I have our server sizing and architecture guide saved on there. I don't actually have any true reports, but we can see just by using an inline frame and a web dev endpoint on a mounted folder, we can see this instantly, pulling up those files. And we'll demo one more with this test text file. There we go, there we have it. One other thing to note is we've set up a lot, we talk about interoperability. We've set up a few template views that have the drop configs tied to our UDTs. So we'll get into how this interoperability works here in a little bit. The next driver I want to look at is the Micro800. So if we go back to the gateway, let's attach to our Micro800. And in our case, we're using a Micro820. So you can see I have that driver here, Allen Bradley Micro800 driver. I'm going to select next. And I'm going to name this Micro820 just so we know what the device is. Again, I know my IP. And as simple as that, we're going to create a new device. And you can see we're instantaneously connected. We talked about addresses and being able to import addresses, but I'm quickly going to demo this. So now we'll come back to browse devices over here. And we'll select on our new Micro820 device. And we can see we have a lot of those variables coming in from our controller. If we go back to our gateway, we're going to come into addresses and we're going to upload that configuration file that we downloaded from our connected components workbench. So we're going to choose that file, choose our Micro800, hit open and load. So again, you can manually come in here and enter these addresses, but having the ability to import those configuration really is a time saver. So we're going to save off that configuration and we'll jump back into the designer. Much like our IEC 61850 driver, we've set up some predefined UDTs. In this case, we're looking at a heat exchanger, and I have a few tags in that UDT, OPC tags, an expression tag, and a memory tag. And what that does, what those are eventually going to do in this demo is help aid our interoperability between these devices. So in my case, I'm going to add a new data type instance, and that's going to be our heat exchanger. I'm going to simply name that heat exchanger, double check that my parameters match. And what you'll see here is we have a triggered switch, which is referencing a tag path essentially back to that breaker. And that's going to be used for this interoperability. So we'll hit apply and come back into the seat exchanger. And now you can see that we have some data here. I'm going to jump into our perspective views now. So we have this Micro800 and we have a single view in here. And much like a lot of our other devices, the drag and drop features of building out these views is very simple, just by dragging tags out onto the screen. But in our case, again, we're using that drop config and using a lot of indirect tag bindings. So just to demonstrate this, if we look over on the left-hand side here, we can see the cooling fans running and we can simply toggle that on and off. Well, if I put myself into correct mode here, there we go. So that's the demonstration for hooking up to both an IEC 61850 device as well as a Micro800 device. I'm going to hand it over to Reese so he can show you similar with the DNP3 and the Mitsubishi Driver.
All righty, let me go ahead and share my screen here. Perfect. So yeah, so thanks for showing those two devices and the connectivity there, Tom. So I'm going to tackle the next two, right? The DNP3 and the Mitsubishi. So to kick us off here, we're going to go ahead and create a new device. So again, I guess I'll mention I'm on the OPC-UA device connections page here, but we'll just go ahead and create a new device. Scroll down to the new DNP3 driver. You might also notice we still have a legacy option as well. But of course, the new one adds all the additional features that we talked about earlier. So that's the one I'm going to use. So we'll go ahead and hit next. And I'm going to keep it simple here for the name. I'll just call this DNP3. For the host name in my environment, I have a 10.20.4.103 is the address for that. I'm going to leave the port the same here as 20,000. Source address is going to be 30,000. And then my destination address is going to be 0. And so I'm going to leave everything else as default here, but of course, in your situation, feel free to update those. But before we move on, I'm actually going to talk a little bit about this data acquisition section, and because this is kind of introduces some of the new features of this driver. So you'll notice we have different pull periods for this integrity pull, or class 0, class 1, class 2, and class 3, and that would be what allows us to pull the data inside those classes at different rates. So I'm going to change this class 1 to change it to 1,000 milliseconds. Notice that it is in milliseconds. We'll change this one maybe to 5,000 milliseconds, and we'll leave class 3 at 10,000. So we have a 1 second, 5 second, and 10 second polling rates for those respectively. Unsolicited event classes down here at the bottom can be turned on as well. This would be a comma separated list for the classes that you want to be enabled. So unsolicited messages are those that do not require polling, but rather Ignition acts as, like a listener for any new messages that that device sends out. So this feature would also be present in the previous driver, but I figured I would just mention it here as well. Expand some of these advanced properties out. Of course, we have some different properties and things to change here with the analog operation and binary operation. But I wanted to mention the logging down here as well, which allows us to turn on application layer logging as well as physical layer logging, just for more granular system logs when connecting up to these devices. So we'll go ahead and create that new device. And sure enough, it looks like we are in fact connected. So with that, let's go ahead and jump into the designer. I'll go ahead and browse over to our, looks like we already have DNP3 tag provider selected. So let's go ahead and look at some of those devices and browse those that we just connected. So expand out the server here, go to the devices, and here's our new DNP3 device that we connected. And here's all the points that we have available to bring in. So I'll go ahead and grab some of these, just a couple different types here, maybe a binary input 0 as well, and bring this over. So now we have 3 tags that are staged for import. So we'll go ahead and hit OK. And so what just happened there is we made a tag that connects up to that DNP3 device, and we can see some of the data here within the PLC. If I open up one of these just in the tag editor here, you can see what happened was we just essentially mapped that tag to that specific location in the DNP3 device. similar to what Tom did, and really similar to all these, we created UDT definitions and templates or visuals for all of those UDT definitions. So let's go ahead and create or view what this UDT definition is. It's just a simple pump station with a basic HOA value here. And you'll notice the OPC item path is going to an analog output number that is specified by the station number param that I'm passing in. Of course, that param is defined here on the highest level of the pump station, UDT, and you can see our station number there. So let's create an instance of that station or that pump station by coming down to new tag, data type instance, and select our pump station. We'll call it pump station 1 and hit OK. And here we have our pump station instance, and our HOA tag is set to 0. And now that we have our data structured in the way that we want, we also have views that we can utilize as well. So here's a pump station template, just a very basic template that I have created. If we throw this into preview mode here, and let's go ahead and turn this on to auto, you'll notice that my tag now has changed from 0 to 1 down here on the HOA, and then we can turn it off, of course. And this will change my value back to 0. So very simple functionality indicating, not only visualization, but also connectivity to that device. So that's the DNP3 driver. Let's jump over now to the Mitsubishi driver. So I'll go ahead and bring the gateway back up, and we'll go ahead and create another device connection here. So we'll scroll down to the Mitsubishi TCP driver, select that one, and hit next. I'm going to call this one Mitsubishi and then underscore IQF because I'm connecting to an IQF series device here. We'll go ahead and specify that here in the series dropdown. Of course, there's the 5 different series we can connect to. I'm going to name my host name here in my scenario. It's 10.20.4.26. The port number I'm also going to change. This is going to be port number 1030. And then everything else I'm going to leave default here. Of course, in your situation, be sure to update as needed. But we'll go ahead and create that new device here. Looks like we are connecting here. And now we are connected. Perfect. So now that we've created a connection to that device, I want to next, actually, before diving back into the designer, is create a mapping of the addresses in this controller. So I'm going to go ahead and click on More, Addresses. And if you've ever used any of the functionality within the Modbus driver, we can certainly create a configuration file to provide this map, or go ahead and add a new row and specify this browse path would be the name of the OPC path and ignition, which would map to the Mitsubishi address in the controller, and then we can add a description. I'm going to go ahead and just kind of demonstrate this. I have some of these already built in here, but I'm going to remove all and start over here and just load a configuration file that we have. I have this locally on my computer. It's just a CSV file, but it is the same tags, of course, that I just deleted. I just wanted to show you that process there. So this is the name of the tag that we'll be viewing in the OPC server inside of Ignition that maps to the specific address. So you'll notice, if you remember back to the slides we had, that's in the D register. This one's specifically the 0 register and bit 0, while this one is the whole D0 register. We also have syntax down here indicating that this is a 32 int value, and that actually spans across 2 registers. So not only it starts at data register 1 here, but also goes and spans across data register 2, because a register is 16 bits, and this has a 32 bits inside of that. So we'll go ahead and save that configuration. And now that we've created that mapping, we'll go ahead and hop back over to the design. Let's switch over to the Mitsubishi tag provider here. And obviously there's nothing configured here, so let's go ahead and do that. We'll go ahead and browse devices once again. open up our OPC server, look at our devices. Here's my Mitsubishi IQF device that I just created. And inside of this, of course, here's the tags for the mapping that I just created. So what I'm going to do is I'll just bring in some of these here just to give a general idea of some of the different values that we have. So we'll go ahead and hit OK. Or I'm sorry, I need to select those before I hit OK. Let's do that once more here. The devices, go to Mitsubishi, go to our tags, go ahead and select again all of the ones that we want to bring over for staging. And now we can hit OK and bring those tags in. So I'm just going to demonstrate some of this here. If you remember, this is the 0 bit, right? I can validate that by double clicking on this and looking in the tag editor. This is the 0 bit of that 0 register. And then this data register tag is that whole 0 register, right? And so if I change this from an odd number to an even number, we should see that Boolean change to off, right? So that shows how those two different types of tags and data types interact with each other, how we can read those values. So let's jump over to the UDT definitions and bring one of those in. Just before we do that, though, we'll check this out and just see it's a very basic UDT, right? A single level member of this UDT. This level tag is being historized, and you can see that it is mapped to the D register that we've defined in our parameter indicator num, which of course, once again, is specified on our highest level of this Mitsubishi level indicator UDT. So we'll go ahead and create a new instance. Go to data type instance, Mitsubishi level indicator. And we'll give this one a name of level indicator 1. Okay, go ahead and select that. And here's our instance. It's looking specifically at that value inside the PLC. It's bringing back a 0. So just to be able to view this now, we'll go ahead and check out the Mitsubishi level indicator template that we've already created. You can see this is a very low level, right? This is indicating a level of, we'll kind of combine all these together. This will make a little bit more sense, but this is just a level indicator template to show where that level is on a scale from 0 to 100. As this level increases, these different indicators here on the right side will light up, kind of giving us at a glance visualization for that. So now that we've created all of our data for all 4 of our PLCs, and we have templates and visuals for those data types coming in, let's go ahead and bring all of these together into one view. So I'll go ahead and create a new view here. I'll call this webinar, since in fact we are on a webinar right now. We'll go ahead and create that. And so we'll just go ahead and kind of utilize the visuals that Tom showed earlier, as well as the ones that I showed earlier, and kind of show some of the interoperability here between these different devices. So I'll go back to Tom's instance here of the IEC 61850, click and drag this onto the screen. Again, this is using that drop config capabilities, right, of that configuration that Tom showed earlier. So now that we have the breaker on there, let's go ahead and jump over to our Micro800 heat exchanger, drag this onto the screen. I'm going to go ahead and just visually connect those up just so we can see that it is being powered by that breaker. And we'll go ahead and show some of the interoperability here right out of the gate. Tom mentioned earlier that, this is pump, it's operating as expected. It's being powered by this breaker. This pump in this heat exchanger is based off the Micro800 data, and the controller, the breaker is coming, the data is coming from the IEC 61850 driver. So when I click this pump, it's going to actually fault out that pump. And what's going to happen is Ignition sees that Micro800 command, and then it sends an IEC 61850 command over to that breaker. So we'll go ahead and turn that breaker on once again and then reset that pump there. And so now we're back up and running there. And we'll go ahead and add these other 2 devices as well. So The next one that we're going to add is the DNP3. I'll grab my pump station UDT, select that one. I'll also drag this one up here just to indicate that the pump is in fact being powered off of that same breaker. Maybe not necessarily the case in a real life situation where everything's powered off the same breaker. In fact, that would probably not be best practices, but for intents and purposes of this demo and showing interoperability, that's what we're doing here. And then we'll go ahead and also add the Mitsubishi as well. So I'll drag this one over. And now you can kind of see where I'm going with this, and that level indicator. We'll line that up right next to the pipe there just to be able to view the level of that pump, or the liquids inside of that pipe, I should say. So we'll go ahead and turn this pump onto auto. That pump is going to turn on, and you can also see the level, of course, in that pipe is increasing as we are pumping liquid through that. So you can obviously see now all of this goes into the interoperability theme that we've been talking about this whole webinar, right? We are connected to all 4 of these devices, and we're bringing all of this data in with really Ignition starring as that middleman to view this data in one central location. So let's once again go ahead and fault out this pump and just kind of show that even further. This breaker is going to trip, which of course turns off my pump, which is being powered by the IEC 61850 driver. And of course, our level is now dropping because there is no more fluids flowing through that pipe. So there you have it, using Ignition to control all 4 of these devices from one screen, and really displaying the power of interoperability that Ignition brings to